Hello, physics fans. How are we doing today? Hope you're enjoying day 2 of not coming to school. I know most of you would like to be here in school, but it is what it is. So we will do as best we can to try to provide some education for you as we go forward. Today we're going to finish out the day, or finish out the chapter that we've been working with respect to efficiency and torque and planetary motion. We'll start going through some of the problems. I will also provide you some word problems for you to do, be able to work yourself through. I'll try to get some solutions up there for you also, so you have a good idea of what we're doing as we go through the material. Happy St. Patty's Day. Happy first day for the Double D. Double D opens up today. Make sure you please keep your social distance. Be safe out there. Today we're going to talk about the idea of efficiency. We've dealt with this last week. We dealt with this a little bit. Efficiency of the machine is work output divided by work input. And once again, these notes are posted for you, so you can work along with the notes as we go through this. But we talked about efficiency of a machine was work output divided by work input, which is your result force times your result distance over effort force times effort distance. Those are things that we have talked about last week. Two new other ideas that we're going to talk about is another way we can calculate efficiency is by looking at what is called a mechanical advantage and an ideal mechanical advantage. These are two other quantities that are given or that can be calculated with respect to a machine. Mechanical advantage is calculated by force output, that's your result force, over your force input, that is your effort force. So whatever your effort force is, we divide that into whatever our result force is, and we talked about our inclined plane. We'll look at our inclined plane here, and we'll go to the example that we did in class last week with respect to the inclined plane and calculate our mechanical advantage. The ideal mechanical advantage is calculated by effort distance divided by result distance. Effort distance, whatever your effort is, what is that distance over the result distance? How far did I push a crate up a ramp? That's your effort distance. The result, what is my result? Raising the ramp up. Or if I was lifting the boxes straight from the ground up, what was the result of that? So that is how we calculate the ideal mechanical advantage. If friction is not present, once again, ideal mechanical advantage is equal to mechanical advantage. These two things are equal. Now, if I'm going too fast for you, you have the capability of hitting your pause button. You can hit that pause button, and you can stop it and then write down what you need to write down and then catch up to it. So, without friction, we have IMA is equal to MA. But our efficiency can be calculated by mechanical advantage divided by the ideal mechanical advantage. Now what we're going to do is we're going to go back to the problem that we did the other day. Okay, where we had the 5 kilogram crate being pushed up, and we had an effort force here. We had mu is 0.1. We have this distance here was 2 meters. We calculated this distance up here to be 5.85 meters. Okay, these were all values from the problem that we did on Thursday when we looked at the efficiency of this ramp. The result force, what is the result force? Well, the result, once again, this is your result. Moving from here to here, this is your result. This is the result. Well, if I was moving a 5 kilogram box from here to here, what work would I have to do? Well, we can calculate the force that we have to exert is 5 times 9.81. That's just the weight of the box. We have to exert that weight to pick it up. Okay, we have to exert the weight. And then we have the 2 meters that we had. and our work result was this value times this value. And then the effort force is we calculated the effort force. The effort distance we calculated by, once again, we dealt with our trig ratio. We had this distance here, and we know this is 2. We had the sine of 20 degrees was equal to this 2 over this effort distance, and we took the value of 2 and divided by the sine of 20 degrees. That gave us our effort distance of the 5.85 meters. Once again, you can refer back to your problem that we did last week on Thursday, and these all these values were calculated for you. And what we calculated then was the effort force was equal to 21.68 meters, or newtons, my bad. So this is what we calculated once again last Thursday. What we want to calculate now is the mechanical advantage and the ideal mechanical advantage. If we look at the mechanical advantage is force, your resultant force, divided by your effort force. Okay, what is my result force? And I divide that by my effort force. So my result force, in this case, is the 49.05. Our effort force, what we calculated our effort force to be, was 21.68, and both of these are in figs. So we can clickety-clack this through the calculator and calculate what is our mechanical advantage. Go ahead and calculate this. And what you should come down is to approximately 2.26. Now this is dimensionless because we have newtons divided by newtons, so we have 0 dimensions there. The ideal mechanical advantage is calculated by effort distance divided by result distance. So this is effort distance divided by the result distance. My effort distance is how far did we push it up the ramp. The result distance is how high did we have to lift it. So my effort distance we calculated to be 5.85. And that is in meters. And my result distance was just what was my result of lifting this up, which was 2 meters. So we have the 5.85 divided by the 2 meters. Go ahead and calculate that. And you should get 2.925. And once again, this is dimensionless because we have meters divided by meters. So to calculate our efficiency can be calculated by the mechanical advantage divided by the ideal mechanical advantage, which is 2.26 divided by 2.925. And we come down to 0.77, which is 77.2% efficient. And if you compare that back to what we did, because the rounding you might be just a little bit different, but we should be pretty much the same. Once again, this is mechanical advantage and ideal mechanical advantage. The pulley system. Okay, let me pause for a second here as we will now do a demonstration of a pulley system.